Hello everybody and welcome back to the Sum of All Alcohol. We are 3 shots of Jaeger in, and we are going to do some standard normal distribution problems. Well, just one problem for this video, and if people request more, I will give them more. I asked my students today what they wanted videos done on, and they gave me the idea for this one. One individual did anyway, maybe a couple other people wanted it too, so here we go. Now, I'm just going to read you out the problem here first, and we can kind of go from there. Professor Halen has 184 students in his college mathematics lecture class. So why don't we start writing some of this down? 184 students. Okay. The scores on the midterm exam are normally distributed. Distributed marks. Okay. Oh, I made the D small. Hold on. We'll make the D big. Yeah, that's right. With a mean of 72.3, and I will go 72.3, and a standard distribution of 8.9. Okay, how many students in the class can be expected to receive a score between 82 and 90? Express the answer to the nearest student. So, how many students can be expected to get between, what did it say here, 82 and 90. Okay, so here is our basic question. It's pretty straightforward, and what we're going to do with this question is convert it into a standard normal distribution. So a normal distribution just means it's got a shape something like that. In fact, that's the standard normal distribution. Let's not do that. Oh, this is going to be fun. Watch this. So we'll bring up Paint, and we will grab a pencil, I guess, and start drawing here. So a normal distribution looks something like that. And I know it looks like a child drew it. You shut your mouth. Okay, there's our horribly drawn axis, and our mean would be in the middle. And normal distributions are symmetrical, right? So even though that's not directly in the center, you understand what I mean. And the mean would go here. Now in our case, the mean was 72. Oh, this is so bad. 0.3, okay? And then one standard distribution away, right about here, would be 8.9 above that. So it would be 81.8. 80. Sorry, I'm trying to focus too hard. 81.2, I think. And since I have been drinking, why don't we just make sure that that's the case? Oh, no, that's bad. 72.3 plus 8.9. There we go. Yeah, 81.2. And of course, you would have another standard deviation above that would be 8.9, and as we go below, we would subtract 8.9, and this would sort of be the distribution of our data. Okay, fair enough. Unfortunately, because every distribution is slightly different, it has a different mean and a different standard deviation, unless you've somehow managed to reproduce the same distribution within software of some kind, then the tools that we have, namely the Z tables as well as other items, are not going to be quite as useful for you unless we were to standardize every distribution into the same type of distribution. Okay? And that distribution is this one, the standard normal distribution. Now, mu in the center is always 0 on a standard normal distribution, and then every standard deviation away is literally 1, 2, 3, minus 1, minus 2, minus 3. Why does that work? Well, because all of our tools are built around standard deviation is a very important factor of those tools and formulas. So by breaking this down, sometimes I tell my students it's called standard deviation form, where every single tick mark on the axis represents one standard deviation. And I'll show you why that's important relatively shortly. Look, can we get this abomination off the screen, please? Okay, just give me 1 second here. I'm going to do one more shot of this Jägermeister. My Jaeger actually has a pump on it, which is pretty odd. Oh, I spilled some. Oh, that's not good. It's on my phone. It's going to be all sticky. Okay, bottoms up, guys. That's good shit right there. Whew. Okay, so what is it that we have to do to get a standard normal distribution? it might be easier to just put up the formula. So I'm going to look for it right here. Perfect. So let me just bring this over to get things into what I might call a Z form. And of course, your standard deviation cannot equal 0 because then you would get an undefined function. Dividing by 0 just doesn't work. You should all know that by now. But the idea here is that we take whatever our x value is, we subtract off the mean, and we divide by the standard deviation. This will get us into a sort of standard deviation form, if you will. Okay? The first thing we're going to do, we have our mean and standard deviation listed. The 184 students don't necessarily matter until the end. If this were a sample instead of a population, and it is a population because it is all his students, right? We have all of his students listed here. And let me just go back. Yeah, he has 184 students in his college math lecture course. So that is every single student. That is a population. If he was talking about 184 marks out of the last 10 times he had run this class, that would be a sample, not a population. But because we have a population, we are good and glorious to go. So why don't we start changing a couple things here. Our upper limit is 90. Okay? That is, and if I bring this picture back, oh, what did I do with the picture? Oh, where did it go? Okay, give me 1 second. View image. That is, if we have, and you know what I'm going to do? I'm actually going to save this and open it in Paint. We'll save that to the desktop, blah, blah, blah. Open up some Paint. We will open from the desktop. It's got to be, this could be it. There we go. That doesn't actually increase it, does it? No. So we are going to turn 90 into a Z score, and that will be our upper limit. Effectively, what we're going to do, and grab a marker. Let's say our Z score for 90 ends up being 1. Well, we want to know everything up to 1, but not past it. Okay, so it'll be, let's say, something like this, where, I know this is terrible. This is what our 90 comes out to be. And then the lower limit was 82, so maybe the 82 ends up at 1 standard deviation. And it's not going to, but it just for an example. We want to find only the shaded area between those 2 points. Well, the problem here is that our Z tables give us a cumulative value. That is, they will give us everything up to whatever value we give it, right? So if we plug in the 90 here, or 1 standard deviation on the Z table, once we standardize our distribution, it's going to give us the cumulative value all the way up to that point. We don't want the cumulative value, we want the partial value, where we've chopped off this remaining portion we don't care about. How do we do that? Well, we'll take the Z value, or the percentage it gives us in the table, at 90, once we've standardized it, and we'll subtract off the value that the table gives us at 82, thereby giving us this entire portion, right? That entire portion. Subtract the portion we don't want. Okay? Does that make sense? If it doesn't make sense, leave a comment down below so I can mock you. Moving on. We'll just close that. So the upper limit is 90, and the lower limit will be 82. Perfect. Going with our standard, and I'll just move this to the side. No, right here. There we go. And I will bring up this. So here, of course, is our formula. So how do we standardize this from our regular distribution into a standardized distribution? Well, it's x minus the mean. So in this case, our x is 90. And we can take x minus our mean of 72.3. Okay. And we'll put that all in brackets just because it's all in the numerator and we want to divide by the standard deviation, which is 8.9. And why am I not just clicking the cell? Beautiful. 1.988764. This is our Z score. Okay. Now down below, if we were to take B3 and make that absolute reference, we can actually drag this down and get 1.08 9888. Okay, so those are our two scores. They're actually above the mid-mark, which makes sense because both of these scores are above the mean. So if I were to drag this over now and bring it to the side, our mean is in the middle. It's 0 when everything is standardized. Both of these marks were above this mean, and both of these Z scores are going to be above this mean of 0 as well. So that's not so bad, right? Right, good. Glad everybody is on the same page. Now, to complicate things further, what exactly do we do to get our Z scores? There is a table here, okay? And unfortunately, I guess I can make it large like that. I will put the link to this in the description if you want it. And we now have to find our Z score on this table. Now give me a second. I'm going to write these down to 2 decimal places. So our upper limit is equal to 1.99. Lower limit is equal to 1.09. So what we do here, oh, that's the wrong one. There we go. We go 1.99. So we start with 1.9. And then we move over to the second decimal place. So you've got the ones column and the tenths column down here, and then you get the hundredths column by going across the row to the corresponding column header. So 1.99, we start at 1.9 and move over to the 9, thereby completing the 1.99. Okay, and this ends up being 97.67%. 97.67% is not bad, but remember, that is the cumulative amount of students that will be up to a score or a test score of 90%. But we still have to subtract off the 82 and below? Let me just check that. Yeah, 82 and below. So that Z score was 1.09. So let's go to 1.0. and go over to 9, and that looks like 0.8621, or 86.21%. And I'm actually going to just blow this up a little bit to make sure. 86.21%. Yep, right there. Okay? Perfect. Let's get this out of the way. Get this back up. So the upper limit here ends up being 97.67%. And the lower limit is 86.21%. Now, if I bring up our paint again, which I know is just absolutely beautiful, both of these are going to be above the mean. It doesn't really matter. This is just an example. But what it's saying is everything up to this point is 90. Oh, it's going to be so bad. 97.67%. And everything up to here is 86.21. Oh, that is just atrocious. But you get the idea, right? So when we do go ahead and chop off this 86.21, it'll leave us with just the small range we're looking for. So what do? We do exactly that. 97.67 minus 86.21. 11.46% of the class can be expected to get between 82 and 90. Okay? But that's not what the fucking question asked, is it? It said how many students can be expected to get between 82 and 90%. How do we find that? Well, number of students. We can take 11.46% of the students and multiply it by 184, or the number of students in the class, to get 21.08 students. And of course, it did tell us to round this number, so we can use our round function. Okay, we can round that number to 0 decimal places, and it will give us 21. So the answer to this one, by using standardization, is 21 students out of 184, roughly, are expected to get between 82 and 90%. Okay? Everybody on board? Good, because I am all done. Thank you so much for watching. If you enjoyed this, make sure you hit the like button so other people who might need stats help can find it. And cheers to you guys. I'll see you in the next one.